Alright, this video is for Algebra 2. I'm going to try to make this a little short. These are your notes for today, just these 4 grids right here. We're going to go through 4 different examples, and then you are free to work on homework. So, we've done this before. We've done greatest common factor, difference of squares, simple trinomial, complex trinomial. So this is nothing new. This is all kind of review, but then we're going to talk about like kind of a little bit about what it means. So we're going to graph these things based upon the results that we get. Okay, I don't have a graph on greatest common factor because a lot of times greatest common factor will just show up in one of the other 3 methods, kind of as like a mixture. So you'll have to factor out something for greatest common factor and then take the difference of squares, or one of the other 2. So greatest common factor. Let's talk about for just a second what makes greatest common factor. Greatest common factor can be any number of terms. So it doesn't have to be 3, it doesn't have to be 2, any number of terms. Okay, so I can't write very well with this pen. Any number of terms. So this one right here has 3. It could be 2, it could be 7, it could be, however many, doesn't really matter. But what you're doing is you're looking for a number or a variable that you can pull out of each one of the pieces that you have. So if I look here, I notice that I can pull 2 out. 2 is divisible by each one of those numbers, right? 2 goes into 6 and 2 goes into 8 and 2 goes into 2, so I'm going to pull a 2 out. But also, each one of those has an x that I can take out, okay? So when you pull it out in front, it doesn't go away. You just leave it out in front and then you write in parentheses what's left over. So if I take a 2x out of here, you'll notice that I have x squared left over. Here, if I take a 2x out of there, that will be a positive 3. Now, again, you're dividing, you're not subtracting. So it's not 4, it's 3. You're taking 6 divided by 2, so that's 3. And I will have another x left over. And then 8x divided by 2 is 4, but that negative stays with it. Okay, so minus 4. And this is what I will get as soon as I do my greatest common factor. Okay, we'll probably come back to this problem here at the end because you might notice that this guy is a simple trinomial, but we'll do that. We'll do simple trinomial first and then we'll come back to this guy. So difference of squares. All right, so difference of squares, what makes it a difference of squares? That first and foremost has to have, number 1, it has to be subtraction. You have to be subtracting in between them, so I have to have a minus sign. And then number 2, I have to have 2 things squared. I'm going to put, I'll just put 2 things squared. That says squared. S-Q-U-A-R-E-D, if you can't see that very well. 2 things that are squared. So you'll notice like 16 is a perfect square. And 64 is a perfect square. So to factor this thing, this is my favorite of the 4 methods, if I haven't already told you that. Factoring this thing down, we have 16 x squared. If I take the square root of that, 16x squared is 4x. So I put 4x here and 4x here. And then if I take the square root of 64, that is 8. So I have 4x and 8 and 4x and 8. And one of them is plus and one of them is minus. Sorry, you can't see this very well. I need to make more room. But 4x plus 8, 4x minus 8. Those are my 2 pieces when he's factored down. Now, we're going to go one step further. And when we are trying to find the zeros of a function. Now, zeros again means the x-intercepts or the roots or the solutions. But if we're trying to find the x-intercepts, you'll remember that we plug 0 in for y. Okay, so I'm going to do that. I'm going to plug 0 in for y. And when I have this broken up into 2 pieces, what I can do is I can set each piece equal to 0. So I have 4x plus 8 equals 0. And then I also have down here 4x minus 8 equals 0. Okay, and if we solve for x on both of those, what I'm going to do is I'm going to subtract the 8 to the other side. So minus 8, minus 8. I'll have 4x equals negative 8. And x will be negative 2. That means I have it touching at negative 2 on the x-axis. 1, 2, right here. He's going to touch right there somewhere. Okay, and then I also have, if I add 8 to both sides, plus 8 plus 8, 4x is going to be equal to positive 8. And if I divide by 4, x is equal to positive 2. So I'll also have a positive 2 on this side and I'll have my dot there, okay? So those are going to be the two places where my parabola is going to cross, and because this is 16x squared, it's a positive 16x squared, he's going to be a smiley face. He's going to look like this, okay? And again, I don't really know where he's crossing at down here. I could figure it out by finding the vertex and stuff, but I'm really more so concerned with the solutions or the zeros, and I found those not by graphing, because I graphed second. I graphed that last. I found that by using the algebra, so the -2 and the +2, because I did the difference of squares and I factored him down. So we were able to find those two places very easy using algebra. So that's what this means when you factor him down and you set him equal to 0. Those two places where he crosses. Okay, so we're going to do that same thing again for simple trinomial. We're going to break him down. So simple trinomial, this guy. Okay, in a simple trinomial, we are looking for 3 pieces, 3 terms, I'll say. Terms, because trinomial means 3. 3 terms, and the other requirement is that it is just x squared, or there's a 1 in front of the x squared. That's what makes him simple. So he's a trinomial because he has 3 pieces. He's simple because he has a 1 in front of the x squared. So this guy is a 1 in front of the x squared. Complex would be a number in front of the x squared. Okay, so if we want to write out the requirements for this guy, still 3 terms for a complex, but there will be a number in front of x squared. Okay, so that's the difference between simple and complex. Okay, so simple, you are looking at what you can multiply to get this number, which is 14, and when you add, give you this number, which is -9. Okay, so multiply to get 14, add to get -9. Okay, so each one of these is going to be x here, and x here. So what can I multiply to get 14, but when I add them, give me 9? And if you need to, you can I want 14. I want 14, not -14. 14. I want 14, so I can list out 1 and 14, or 2 and 7. Those are really the only 2 combinations that multiply to get 14. So which one of those is going to give me -9? Well, it's going to be the 2, 7 combination, right? 2 and 7, and maybe you could do that without listing them out. That's great. Now we also notice that I need a -9, so both of these are going to have to be negatives. -2 times -7 will give me 14, but -2 minus 7 will give me -9. That checks out. Okay, now as soon as I have them factored down, I want to find those zeros. I want to find where they cross. So I am going to set this guy equal to 0. Equal to 0. And when in doing that, I will set both pieces equal to 0 individually. So x minus 2 equals 0, and x minus 7 equals 0. Okay, and if I want to get x by itself, I would add the 2 to the other side. That's a -2. I would add the 2 to the other side, so x would be +2. All right, that's one of my solutions. And if I add the 7 to the other side, +7, x will be +7. Okay, so there he is. So I have a place at 2. 1, 2, there's a dot. 3, 4, 5, 6, 7. There's a dot. Okay, and so I have this guy, and he's going to be a smiley face because he's +x squared, so he's going to look like this. And I don't care how far he goes down. I'm really just concerned with those 2 places because I'm trying to find the solution. So 2 and 7. Okay. Later on, we will incorporate the vertex and stuff in there too, just kind of putting it all together. But for the purpose of this, I am just concerned with those 2 pieces. So I don't really care how far down he goes. So there's simple trinomial. So there's those 2 methods. Now let's bump back up here. And if we were to factor this down, just give us some extra practice, what would you multiply to get -4, but when you add them, give you 3? So let's look at that. Multiply to get 4, add to get -3, or add to get +3. Multiply to get -4. So thinking about those, I have 4 and 1 or 2 and 2. Those are the numbers that give me 4. But 4 and 1 is the only combination that's going to give me 3 when I add them. So, and I need it to be a +3. So I'm going to make this +4 and -1. Okay. I'm not going to go ahead and set this equal to 0 because we have this 2x out in front, and then we have like all 3 of those pieces. So we're not going to worry about that for now, but this is just more practice of multiply to get this, add to get this. So that's a simple trinomial as well. So this was a combination of greatest common factor and simple trinomial. because that's what will happen most of the time, is greatest common factor will be with something else, okay? All right, complex trinomial, last one. This one is the hardest and probably the most steps of each one. So the first thing that you're going to do, step number 1, is I'm going to do A times C. And what the heck does that mean? Your A value is the first one here, so 2, and C is the last value, negative 10. So I'm going to take 2 times negative 10, and I'm going to put that over here. 2 times negative 10 is negative 20. And then I'm going to start listing out factors of negative 20. Now, I want to multiply to get negative 20. Multiply to get here, just kind of like how we were doing over here. Multiply to get negative 20, but when I add them, I want to get this middle number, which is 1. If there's no number here, it is 1. I want to add to get that number. So multiply to get negative 20, add to get 1, okay? So I can list out like 1 and 20, or 2 and 10, or 4 and 5, and some of you guys are really frustrated because you've already got the answer. 4 and 5 is the combination that you want to get 1, okay? So what I'm going to do now in step number 2 is write 4 pieces. 4 pieces. Okay, so I'm going to take this guy and write the 4 pieces. So 2x squared is going to stay the same, and the minus 10 on the end is going to stay the same. Okay, but that middle piece right there, that 1x, is going to break down into the 2 that I had over here. So it's going to break down into 4x and 5x. Now, which one's positive, which one's negative? If in order to make a positive 1, I would need positive 5, negative 4. And that's what I would need to do, okay? Now, you're going to get the correct answer. You're going to get the same answer at the end if you would instead have put 5x here and negative 4x here. You'll get the right answer. Your middle steps will just look different than mine, and that's okay. So now, as soon as we do that, step number 3, we're going to group. Because this is factor by grouping, or sometimes I'll call it Cody's method. I don't know. So factor by grouping, we're going to group those two, group these two, and we're going to see what we can pull out. So out of this piece, you can pull out a 2 and an x. So I'm going to do that. If I take 2x out of this part, I'll have an x left over, and if I take a 2x out of here, I'll have minus 2. Okay, and then out of the second piece, I can pull a 5 out. So let's do 5, and left over is x minus 2. And at this point, I know that I did it right because, oh my, I didn't mean to do that. Because, now I should just shut everything off. No, yes, that's what I want, right here. Okay, don't do anything weird. This piece and this piece match each other, okay? So, if I look at those two pieces that match each other, x minus 2, and I yank that out, yank that out, what's left over? 2x plus 5. That's my other group. 2x plus 5. Okay, so step number 4, I'm going to say after you group it, you pull out your GCF and simplify. Simplify. Pull out your GCF and then you simplify. So these are my 2 pieces. Now, if I want to graph that, I need to first set those equal to 0. So we're almost done. Setting them equal to 0. Equals 0. Okay, so I have over here x minus 2 equals 0. Equals 0. And I have 2x plus 5 equals 0. So if I add the 2 to both sides, x is equal to positive 2. And if I do this one right here, I would need to subtract 5. Okay, so let's do that first, and then I'm going to rewrite. So 2x equals negative 5. And then I would divide by 2. Okay, negative 5 divided by 2 as a decimal is negative 2.5. And that's fine. We can get decimals. That's okay. So I have my 2 answers are 2 and negative 2.5. So I'm going to graph those 2 places. I have 1, 2, put a dot. And 1, 2, 3, 2.5 will be about there. And gosh, I made this kind of boring because all of these are smiley faces, right? If I look at this first piece, that's a positive. So he's going to be a smiley face. So he's going to look like this. So using algebra and my factoring methods, each one of these 4 factoring methods, I was able to find where my zeros are located. And I did that by factoring and not by graphing. So that was exciting. We graphed second. We still did graph, but we graphed second. So that was exciting. We were able to do that by just doing the algebra stuff. Okay, so your homework assignment on the front side is just doing the basic breaking these down, factoring, and then the back side is when you're going to have to graph. And there's only a couple of those. So there's that.